Welcome everybody to Wednesday Night at the Lab and this special Friday night edition of Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for the Division of Extension 4-H. And on behalf of those folks and our other co-organizers, PBS Wisconsin, the Wisconsin Alumni Association, and the Science Alliance of UW-Madison, thanks again for coming to this special Friday night edition of Wednesday Night at the Lab. Tonight, it's my pleasure to introduce to you both Professor Tracy Holloway and Professor Bassam Shakashiri. They're going to be giving us insights into the challenges of climate change. Professor Tracy Holloway is a 2017-2021 Gaylord Nelson Distinguished Professor here at UW-Madison. She's jointly appointed in the Nelson Institute for Environmental Studies and in the Department of Atmospheric and Oceanic Sciences. She serves as the team leader for the NASA Health and Air Quality Applied Sciences team, which connects NASA data with stakeholder interests in air quality management and public health. Tracy is a co-founder and served as the first president of the Earth Science Women's Network, goes by the acronym of ESWN, which has a mission of supporting the scientists of today and welcoming a diverse community of scientists for tomorrow. Among her awards, Holloway was the first ever recipient of the MIT C3E Award in Education and Mentoring, the 2018 UW-Madison Undergraduate Research Student Mentoring Award, the 2019 UW-Madison Phi Beta Kappa Excellence in Teaching Award, the 2020 Ascent Award from the American Geophysical Union. Dr. Holloway earned her Bachelor's of Science in Applied Math from Brown University and a PhD in Atmospheric and Oceanic Sciences from Princeton University. She'll be our second speaker tonight. Our first speaker will be Professor Bassam Shakashiri. He is a noted chemistry and science educator. He is probably best known for his leadership in national science policy, promoting excellence in science education at all levels, and for his development and use of demonstrations in the teaching of chemistry. His scholarly publications, including the multi-volume series Chemical Demonstrations, a Handbook for Teachers of Chemistry, are models of learning and instruction. He's an advocate for policies to advance knowledge and to use science and technology to serve society. He promotes the exploration and establishment of links between science, the arts, and the humanities, and the elevation of discourse on significant societal issues related to science, religion, politics, the economy, and ethics. Would you please join me in welcoming both Professor Tracy Holloway and Professor Bassam Shakashiri to Wednesday Night at the Lab. And Bassam, if you'd like to start, that would be great. And then I'm gonna take my video off, and if other people would do likewise.
Bassam, we can't hear you. I think you're muted.
Thank you so much. Now you can hear me. May I have the next slide, please? We try to link science, the arts, and the humanities in so many different ways. And soon we will be able to be together doing things in person as we want to foster community appreciation of science. We want to cultivate creativity. We want to explore, learn, and share. And we always want to obey the safety rules. That's why I'm wearing my 2 masks here, even though I'm at home in this room by myself. So I share that with you to emphasize the importance of being role models. Next slide, please. Global warming is unequivocal. That's one of my 2 major messages this evening. Global warming is unequivocal. And I want to share with you some observations and some notions about why global warming is unequivocal, and how we can, in my second takeaway message, try to mitigate changes in the climate. Climate changes are inexorable. We can't stop them, but we can slow them down. And so on the next slide, I share with you the major greenhouse gases: water vapor, carbon dioxide, methane, and nitrous oxide. And today, this evening, I will focus on water vapor and carbon dioxide. And I want to say right up front, right away, greenhouse gases are good for us. If it weren't for greenhouse gases, the temperature on the surface of our planet would be close to the temperature on the surface of Mars. But too much of anything is not good. We have been spewing into the atmosphere more carbon dioxide than ever because of our reliance on fossil fuels as a source of energy. Water vapor we can't do much about because of the water cycle. Everyone knows about the water cycle. But global warming contributes to putting more water in the vapor phase. And we'll talk about the properties of both of these substances very shortly. So we start out with carbon dioxide on the next slide, please. Carbon dioxide exists as a gas. It's invisible. It has no color, no smell. We can't see it. We can't smell it. Under certain conditions, we can have it as a liquid also. A lot of people know about carbon dioxide as a solid. Can you show me via full, show what I'm holding up here? So, so here's a chunk of dry ice, and it is solid dry ice. I have been joined by my dog in the background. If you may hear my dog, but that's okay. So dry ice is solid carbon dioxide. Yes, he's sharing his greetings with you. And solid carbon dioxide changes directly into a gas without melting. So we go back to the slide, the same slide, Bia. Yes. Solid carbon dioxide changes directly to a gas without melting. We call that sublimation. And gaseous carbon dioxide is a greenhouse gas. Its chemical composition is 1 carbon atom and 2 oxygen atoms. Any molecule in the gas phase that has 3 atoms or more is a greenhouse gas. There are lots of explanations and reasons for this, but we will not go into that this evening unless you wish to bring it up in the question and answer period. So we go to the next slide. Carbon dioxide, of course, is crucial to us in the process of photosynthesis. And photosynthesis happens during the day because the reaction between carbon dioxide and water is catalyzed by sunlight. Now, because of our dependence and reliance, over-reliance on fossil fuels as a source of energy, the combustion of these fossil fuels yields a lot of carbon dioxide. So on the next slide, I share with you the latest, near latest, it's a month old now, reading from the top of Mauna Loa Observatory in Hawaii. This is the famous Keeling Curve. And it's a rather interesting curve because you can see since the 1960s now through the 2020s, the curve seems to be smooth and increasing. This is a direct measure in units we call parts per million, which are really tiny, small units of measurement. This is a good telltale of how much carbon dioxide we're putting into the atmosphere. To put this in perspective, on the next slide, please. 1 part per million is equivalent to 8 gigatons. And that, if you if you approximate, as I'm going to now, the population of the world to be close to 8 billion people, that's about 1 ton per person. And you and I know that the industrialized nations are the nations that contribute more than 1 ton per person because of our over-reliance and dependence on fossil fuels. And that's why it is crucial for us to really take specific action to lower our dependence on fossil fuels and use alternative sources of energy, clean energy. It's good for us, it's good for the economy, it's good for the environment, it's good for the biosphere that we lower our usage of carbon dioxide material that contribute to global warming. The next slide, I share with you some observations about water. It's a unique substance. You and I know it's the only substance that exists in 3 stable forms: water vapor, liquid water, of course, and ice. So let me show you on the next slide a small representation of an experiment. So on the far left, we're about to drop an ice cube, and we mark the level of water. In the middle, we see that the ice cube floats. Of course, we all know that ice floats. That's a very fascinating phenomenon. That has to do with the properties of ice. And people ask, why does ice float? In fact, if it weren't for ice floating, life as we know it on our planet would not be. But you notice that when we put the ice cube in the glass, the level of the water rises. Now, I said what I said very carefully. Notice that when we put the ice cube in the water, the level rises. That's because I want to talk about glaciers that break off from land and go into the oceans, not about icebergs. Now, when the ice melts, as you see on the far right of this slide, then the level of water is higher than before. And this is what we have to be very concerned about, because rising levels of seawater will have an adverse effect on all the cities and all the lands that are near bodies of water. The next slide shows a glacier. Again, I say this effect is because of glaciers breaking off, not icebergs. Icebergs are already floating in the water. So on the next slide, I show the variation in sea level in the past 25, 30 years or so. The measurements are in millimeters. You might say, well, that's a small unit. Yes, it's a small unit, but it has consequences. And you can see that the trend is upward. So rising sea levels is of great concern to us. And this is a telltale of global warming. Now, what I'd like to do is share with you some more immediate and local telltales of global warming, and that's on the next slide. This is a depiction of the plant hardiness zones in Wisconsin. On the left side, you see a 2-decade span from 1980 to 1999. On the right is from 2000 to 2018. Anyone, a third grader, can see that we have a very direct and strong telltale that global warming is affecting us. This is a very important part of our knowledge, of our observations, that we should always be using to be convincing ourselves and others as we share the concerns we have about global warming, that there are effects, serious effects that are occurring. On the next slide, we see a depiction of the dates of ice on the surface of Lake Mendota. Ice off is in the upper part of the slide. Ice on is in the lower part. And you can see the trends are very, very clear and very obvious. You can also see that the variations in these data are different than the variations in the Keeling curve. The Keeling curve changes were symmetrical. Here, they're not symmetrical. Those are all kinds of interesting questions that we ask ourselves in science. What are the explanations for these variations? What are the differences that we have? So I would like now to go back to full screen, please. And Bia, can you, let me see, can I see who else is on the I'm looking for a special person that I invited. Is this person with us or not? I don't see that that this person is with us. All right, so so Bia, let's go back then to the slides, please. The next slide is what can you do? Remember, my two takeaway messages. Global warming is unequivocal, and the second one is what we can do, what we must do. So the first thing I suggest is that we increase our scientific knowledge of climate change. We have to know the basis and understand what is it that we're talking about when we say that global warming is unequivocal. We have to commit to taking responsible action to help mitigate global warming. And I suggest that we engage in conversations about global warming with family members, with friends, and others in the community. I suggest that we engage in respectful conversations so that we are able to share and communicate effectively what we must do in order to mitigate global warming. And I emphasize the word respectful. There are people who don't want to have such conversations. I ask that we respect them as fellow human beings, not necessarily respect their views or their opinions. So it's crucial to us to engage in respectful conversations and not talk at people or talk to people, but talk with people and listen to the concerns that they have. So we have to be respectful, we have to be trustworthy, we have to be confident about what we're saying when it comes to global warming. On the next slide, here are some suggestions for immediate personal action that we can take. We can buy less stuff. You know, the adage, reduce, reuse, recycle. And if you haven't done so, change those light bulbs. And don't keep them on either. I'm about 90% LED in my house now. Use a programmed thermostat. Eat less meat, especially beef. You might wonder why this is related to global warming. We can discuss that later in the Q&A if you like. And let's walk and bike and use more public transportation when we're able to be outdoors and to travel safely. And let us fly less because the carbon footprint is affected by all of these entries that are listed here. And switch to a car with a better fuel economy or an electric vehicle. In my case, I have a hybrid car, which is good. It's better than having a gasoline dependent car. And the last bullet I have here is to make sure that every eligible voter votes in every election. It's crucial that we exercise our right to vote and to participate in our democratic process. And if you're not of voting age, please encourage those in your family to take action and to vote. I don't dare ask how many people voted in yesterday's election. Two days ago in the election in Wisconsin. Maybe I will ask later during the Q&A. Why is voting important? On the next slide, which emphasizes again that you let us all vote in every election. On the next slide, I share with you the conviction that I borrow from President Lincoln, who said, public sentiment is everything. With public sentiment, nothing can fail. Without it, nothing can succeed. We must influence public sentiment. We must work hard to share our understanding of the different factors that impact what is happening in our biosphere so that we succeed together to benefit all of humanity. On my next slide, I say again, global warming is unequivocal. I invite you to visit my website on the next slide, if you haven't been there already, where we have a variety of information related to climate change, but we have other information as well. And I thank you for including me in this evening presentation. I'm very proud to be part of Science Expeditions, a very important activity that we have at the University of Wisconsin-Madison. And I now turn it back to Tom.
Thank you very much, Bassam. It's a pleasure to have you here, and thank you for sharing your insights. Professor Holloway, would you like to go next?
Yes, absolutely. Let me share my screen. And turn it to the. So it is such a pleasure to be here tonight, and a real honor to follow Dr. Shakashiri. I've been an admirer of his work for a very long time. So Dr. Shakashiri walked us through some of the science of climate change. And I'm going to be talking to you for the rest of the session until the Q&A about some ways we can think about solving this climate change challenge. And I want to start out by saying that we actually have a pretty good track record of solving these big atmospheric challenges. And I'm going to start out by talking about the ozone hole over Antarctica, air quality over the US, and conclude talking about climate change, the topic of the day. I'll get to my punchline first, though, which is to say the ozone hole was discovered in 1985, and binding international regulation was in place 2 years later. And you could really see that curve of the pollution causing the ozone hole went from up to down just a couple of years after that. In the US, we've known about air pollution for hundreds of years. And in 1970, the Clean Air Act was written, the EPA was formed, the first Earth Day was launched, and that turned the corner. Our air started getting cleaner and cleaner after that, which brings us to climate change. And I'm hoping that we can look back on the 2020s and see that this is when we turned the corner and began solving the climate change problem. And to get us in the mode of thinking about climate change, I think it's always good to start with some lessons learned, some proven successes. So let me tell you a little bit about the ozone hole. When we're thinking about the ozone hole, we have to first keep in mind that there's this natural protective layer of stratospheric ozone all around the Earth. It's way up high. You may have heard of ozone as an air pollutant, which it is when it's near the surface where we breathe it. Just like you like to have sunscreen on, but you might not want to eat it. It's good to have sunscreen way up high in the natural ozone layer, but we don't want to breathe it at the surface. But way up high, ozone is a good thing. And so it was very surprising in 1985 when scientists from the British Antarctic Survey noticed that in the Antarctic springtime, there was a big depletion in this natural ozone layer. And looking at it from the chemistry and the measurements and satellite data, they figured out that the cause was chlorofluorocarbons, an industrial chemical that came from air conditioning and computers and a lot of other sources. And 2 years later, countries around the world signed a treaty, the Montreal Protocol, and that started cutting the ingredients that were the cause of the problem, the CFCs, the chlorofluorocarbons. And we can see each year in the satellite data from NASA, and there's a great website called Ozone Watch linked at the bottom of this slide. And we can see that actually the ozone hole, it does form every year, but it is getting better. And I want to show you, zoom in on some of the data you'll see here in a minute. But first to say that these ingredients, these causes of the ozone hole, you could see that in the early 80s, they were going up and up and up. Shortly after the Montreal Protocol in 1987, we turned the corner. They started plummeting. And just as the release of the chemicals into the air went down, we could see that their concentrations in the air also were going down, down, down until 2010. And measurements picked up that the concentrations were beginning to creep back up. And this was due to illegal emissions. So they were identified. And in fact, we've turned the corner then again, and they've been controlled. And now we're seeing the decline in those levels again. But I think this is an interesting example because, first of all, it's a success story. The problem was identified, policies in place, and we turned the corner. But also recognizing when you have the whole world working on a problem together, especially related to invisible gases, there may be some bad actors. And it's really, to me, reassuring to see that the science picked up on the problem with the ozone hole, and there could be a policy response, and that's been solved as well. If we want to see what's happening to the ozone hole itself, it has been getting smaller since 2006. So for almost 15 years, it's been getting smaller, some years a little bit smaller, some years a little bigger. And the amount, how deep the hole is, has also been decreasing. So ever since 1994. So when you think about the ozone hole, I hope you'll share with me, share my opinion that it's really a success story. It's really viewed from the international environmental policy community, the atmospheric chemistry community, as a success story because there was a global agreement to protect the atmosphere, the ozone hole is recovering, and satellite and other data can track the progress, including when there's some illegal activity. So let's go to the next good news story. And this is really for US air quality. We've known about bad air pollution for a very long time. In the 1800s, some cities had smoke ordinances. But there were two really high-profile events around 1950. One was in Donora, Pennsylvania, and one was in London, England. If you watch The Crown, you might remember that one episode in season 1 where they really focus on this bad air pollution episode in 1952. These events and others really raised air pollution as a high-profile issue. So when the EPA was formed in 1970, the Clean Air Act was signed that same year. And ever since then, the 6 major pollutants regulated for their health impacts, their direct health impacts, have been going down, down, down. And that means our air has been getting cleaner, even as our economy has grown, the number of miles traveled has been growing, our population has grown, and our energy use has grown. And unfortunately, even our CO2 has been increasing. So these air pollutants we've been able to reduce in part by having cleaner burning engines and controls on the stacks of power plants. So we've been taking really effective action on US air pollution. Unfortunately, it hasn't been action that also reduces CO2, but we'll come back to climate change and carbon dioxide later in this talk. If you want to think about what the world was like before 1970, you can look at some old movies like Rocky. Many of you may remember it. I wasn't alive before the Clean Air Act was formed, but there are photos like this on the web of Boston. And of course, this is not what it was like every day, but air pollution varies with the weather. And when the weather conditions trap local pollutants, they can build up to unhealthy levels. That's true today, and it was true in many parts of the US in the early days of the Clean Air Act and before that. The reason we care so much about air pollution is because it kills people, it leads to asthma attacks, and it has other negative impacts on crops and ecosystems. But this, to me, the most striking evidence of how unhealthy air pollution is came from that 1952 London episode. And this is a plot showing sulfur dioxide, one of the pollutants that we still regulate in the United States, mostly from coal. And that when those weather conditions came and trapped that SO2 over London, think about all those street lamps and burning coal, the concentrations ramped up. And during those same times, the number of people who died each day also ramped up. Here it shows the weekly mortality count, which was up to 5,000 at the peak of the pollution episode, over about triple what it was before that. And you can see that even when the air cleaned out, the winds came along, the pollution blew away, but the mortality count stayed high for 3 more months. So this same kind of approach is still used to quantify the health impacts of air pollution, but it's rarely as obvious as it is in this plot here. But the good news is that the controls put in place from the Clean Air Act have reduced all of the major pollutants that affect human health known as criteria air pollutants. And so these successes, what can we learn from them? Well, one thing we can learn is that having ground-based measurements to see what's in the air can be a very effective way of seeing what's happening, but also that satellite data, just like it was for the ozone hole, is a powerful tool in our toolbox. Satellites can see many chemicals in the air, even ones that are invisible to the human eye. And as Tom mentioned during that very nice introduction, I lead the team for NASA trying to make satellite data like this more usable by states, including the Wisconsin Department of Natural Resources, cities, health organizations, and more. And one of the reasons this is such amazing data is that we can see where chemicals are being released. And here you see nitrogen dioxide, but actually the sources of nitrogen dioxide are the same sources for the most part as carbon dioxide that affects climate. Now, here is data from 2005, the first year that one of these major satellites was put into orbit. But look, 2019, many cities across the United States just over this time period have seen reductions in nitrogen dioxide by 40% or more. So when I think, and you've probably also seen some of these images from satellite data about pre and post shutdowns of the 2020 pandemic. So the satellite data can be very powerful to look at trends in our energy use, what chemicals are being released into the air, and how they change year to year and even month to month. So when we think about US air quality, it's really another success story. There's a US policy in place to protect the atmosphere and health. Air pollution is decreasing, health is improving. Now, just like the ozone hole, it's not a solved problem, but we've turned the corner and we're on track to be solving it. And my question is, how can we learn from these success stories and take some of these same lessons learned and apply them to climate? So one of the projects that I'm working on in terms of climate change is I participate in a program called Science Moms. And this is a really fun project for me to be part of because I've been a scientist for 25 years, long before I was a mom. But now I also have an 11-year-old and a 1-year-old. And I was invited to be one of the founding members of this Climate Moms program with the idea that climate can be very confusing. And while we all need to take a role in solving the problem, we don't all have time to be studying textbooks and learning everything that we could know. And so the Climate Moms program has tried to take some complex information and boil it down in a way that is scientifically correct. There's a whole board of us advising it, but also engaging and even entertaining. There are book recommendations, videos, Instagram feed, and more. This is the 6 of us who are the original Science Moms. We've since grown our cohort by 2, but the initiative is a nonpartisan group of climate scientists who are also mothers. And our goal is to have get the word out on climate change, answer questions, and make this kind of intimidating and sometimes confusing topic accessible to everyone. You don't have to be a mom to visit our resources. So I mentioned that I'm part of this group, and I think that when I've been thinking about climate change and environmental change for a long time, and I remember it used to seem like 2020 was far away, and now that's in the rearview mirror. And 2050 and 2080, these are all kind of benchmarks when we think about what's going to happen to our world. What is our future going to be like? And I used to always think that 2050 was so far away, but now this is my baby Henry. He turns 1 next week, and he'll be turning 30 in 2050. It suddenly makes these far off issues of climate change very personal to me. And I know a lot of us who are concerned about the future are really trying to think about how can we leave the next generation a world that has passed the turn the corner, where we can talk about the changes that are underway, even if the problem isn't 100% solved. So many of the next points overlap with Dr. Shakashiri's, but I just wanted to, these are pulling from the Science Moms website, but making the point that climate change really is settled science. And I'll say I got involved in climate science from a very nerdy scientific way. I say that in a good way. I came from an applied math background, and I started working at a climate modeling lab. And the more I was learning about how the atmosphere worked, how we track hurricanes, what makes a cold front move in, you really can't think about how the atmosphere is working without understanding how it is changing on the long term, from year to year, like El Nino, and those kind of forcing factors, but the important role that human activity is playing in changing the climate as well. There are a lot of natural processes that affect the climate, but human burning of fossil fuels is really what is at the heart of climate change. We've been taking carbon that's been in the earth for millions of years and using it for so many energy sources, our cars, electricity, industry, and more. But the good news is there's a lot we can do about it. There are so many solutions on the shelf ready to go that are cost effective. And when I think about what the solutions are, I always like to think, what is the problem? Where is CO2 coming from? And this is a breakdown for the United States from 2016, so it's changed a little bit. But basically about 1/3 of our CO2 comes from transportation, cars and trucks, shipping, airplanes, construction equipment. About 1/3 comes from the electricity sector, 1/3 from industry, and then also some for home heating and cooking and agriculture. But when we think about solving the climate change problem, there are so many solutions, because when you start thinking about transportation, just like Dr. Shakhashiri mentioned, there's public transport and biking, but there's also improvements in automobile technology, improvements in where we're getting our electricity from, and improvements in industrial processes. One framework that is becoming widely adopted as a sort of short path to a climate solution is trying to get everything or as much electric as we can do so in a cost-effective manner. And then once we convert everything to electricity, do so in a concurrent with converting our electricity grid to being zero carbon. I'm doing work with Madison Gas and Electric, who has announced a plan for net zero carbon by 2050, and many other major companies and electric utilities and governments are really thinking about how to make the electricity grid clean, and then how to take energy use and fossil fuel use like gasoline and move it onto this clean electric grid. So whether that's home heating as electric or electric vehicles or other ways to be moving toward electricity and making the electricity from non-emitting sources. So one of the things that I study is air pollution, and I study all the chemicals in the air, but I'm especially focused on the ones that make people sick. These are the chemicals that were regulated under the Clean Air Act and are still a problem for many parts of the world, and actually even in the US, almost half of our population lives in areas that are still above this health-based standard. So the air is getting cleaner, but we're still working on it. But I'm trying to think about what are ways to find win-win solutions, ways to reduce our carbon emissions and make the air cleaner. So a few years ago, I did a project with the National Renewable Energy Lab, where we took their aggressive scenario of solar energy, which was about 20% of solar energy in the Eastern United States coming from solar, and tried to calculate what would that mean for clean air, what would it mean for public health. Now, you don't have to pay attention to this graph if you don't want to, but bear with me while I just say a few things about the study results that we found. We used a computer model to say, well, what if the Eastern United States got 20% of its electricity from solar? Now, in that case, we would still have some days that were clean, some days that were dirty. But the question is, are all days getting cleaner with solar energy, or is it making the dirtiest days cleaner? Because that's what we want. We want to have fewer and fewer of these really dirty, unhealthy days. And if we can do that while moving away from carbon emitting electricity, it's a win-win. And luckily, what we found is exactly what we'd hoped for, that on the dirtiest days, that's the x-axis, that's sort of how much PM 2.5, the number one health damaging air pollutant, is in the air. And then the y-axis is saying what would be the benefit of solar energy on those days. And what we found is that solar had the biggest benefit on the dirtiest days. And consistent with other studies, we found that the number one benefit accrued to areas in the upper Midwest that have a lot of coal-fired power plants. Because if you're not running those coal-fired power plants as much, then the air will be cleaner in those areas, especially. So I wanted to end here with the link to the Science Moms website and my friend and colleague, Catherine Hayhoe. And her TED Talk here was entitled, "The Most Important Thing You Can Do to Fight Climate Change is to Talk About It." And that's exactly what we're doing here. So it's been really a pleasure to be part of this conversation, and I look forward to the question and answer.
Thank you very much. The way we do Q&A generally is that we ask anybody who would like to unmute themselves and go ahead and ask a question. In the meantime, Bia watches the chats for anybody who would like to ask a question by chat. So why don't I open up for stated questions? If anyone has a question that you would like to speak to either Professor Holloway or Professor Shakashiri.
Could I take advantage of the fact that I saw an important question in the chat and attend to it right now?
Absolutely.
And so the question came, at least two people asked, what is this about any molecule in the gas phase that has 3 atoms or more being a greenhouse gas? It's not because I say so, it's because it's scientifically known that molecules consist of atoms, and the atoms are held together by what we call bonds. They have bonds of shared electrons between the atoms. Sometimes the atoms, when they're different from each other, attract the electrons closer to one side of the molecule than the other one. In other words, they create an uneven distribution of sharing of the electrons. And we call that a dipole moment. There is a partial positive charge on one side of the bond and a partial negative charge on the other side of the bond. So that's when we have 2 atoms in one molecule. But what I said was it's 3 atoms. How come it's 3 atoms and not 2 atoms? It turns out that the bond energy that holds these atoms together, the bond energy includes what's called vibrational energy. The vibrational energy is in the region we call the infrared region. Now, we all know about the infrared region because right now, I'm going to ask you to rub your hands like this very fast. Rub your hands, rub your hands. What do you feel? I saw somebody mouth because you're muted. Yes, you said heat, right? Yeah, you feel heat. Well, this is the heat energy that corresponds to some of the vibrations of the molecules in the gas phase. Well, you might say then if a molecule has uneven distribution of electron density in one of its bonds, then it's going to be active, as we say, in the infrared region. And that's what makes it a greenhouse gas. And sorry about this long explanation, but it's a mini chemistry lesson here. Well, you might say two atoms, like the gas carbon monoxide, not carbon dioxide, the carbon monoxide has two atoms and has uneven distribution of electron density in between. How come it's not a greenhouse gas? Well, it's because it doesn't last long enough in the atmosphere. The lifetime is another consideration. There's another substance, hydrogen chloride, also has an uneven distribution of electron density. It's responsible for, among other things, acid rains, part of acid rains. Well, how come it's not a greenhouse gas? It's because it doesn't last long enough in the atmosphere. So there are different considerations that relate to making the statement that I made. So lifetime, where they are in the atmosphere, how long they last in the atmosphere, all of these factors contribute to having the statement that I made be valid. Does that help?
Yes, thank you. And then, Bia, do you want to read the question in the text to both professors?
Yes, I can. So it looks like the next question is from Jennifer. I don't know which professor this would best go for, but I'll just read it out. What is the biggest change in climate that you have noticed in your lifetimes, and how has it been addressed?
And Professor Holloway, if you'd like to go next.
Sure. Well, I spend a lot of time looking at data. So this is not drawing just from my personal experience, but the winters here in the upper Midwest have gotten warmer. And they've gotten warmer over 10 degrees Fahrenheit on average. I have to go back and look at the exact data, but it's a pretty significant warming. And I think to me, I remember I grew up in Chicago and it was so cold in the winter. I mean, every day I was wearing long underwear and bundled up. But here I'm living in Wisconsin, which is even colder. And really there's many mild days through the winter. And there just isn't sometimes we have very bitter weeks, a few bitter weeks, but it just isn't the norm anymore, the way that it was when I was growing up. And you can see that in the data. Professor
Shakashiri.
I would say in my 50 plus years here as a faculty member at the University of Wisconsin-Madison, the most noticeable change is, of course, what Tracy just mentioned. But for me, because I live on Lake Mendota, is seeing that the duration of the ice is getting shorter and shorter every year. Not every year, but the trend is that way. And so being a witness to a very significant telltale is sobering to me.
Yeah, I think it's interesting that we talk about global climate change and global warming, but here in Wisconsin, the big change is not how hot the summers have become, but rather how warmer the winters are. And this is one of the cool things about looking at the data every which way you can. Bia, do you have another question?
Yes, this question is from Zara. And she asked, are there ways to grow or consume food that will help with confronting climate change?
Maybe I'll start with that one, because actually that's a great question, Zara. And you're right that the food we eat has kind of embodied in it a lot of energy use. And that energy use can come from different sources. One question is, how far did the food travel to get to you? Because it had to travel by plane or boat or truck, and that was burning fossil fuel. But there's also the question of what kind of packaging is the food in? And how was it grown? Was it grown in a greenhouse, or was it grown in an open air farm? And so all of these things play a role. So actually, I had a number of students years ago, about 10 years ago, and they developed an iPhone app that could scan the barcodes of grocery store food items and calculate what was the carbon footprint of different food items. And one of the things they found was that actually the container was one of the biggest contributors. So one thing you can do is if you're buying soup, instead of buying it in an aluminum can, buying it in a paper box. So that's something that can reduce the impact. But another thing is to eat in-season vegetables that didn't have to be, and fruits that didn't have to be grown in a greenhouse and didn't have to be shipped in from far away. And like Dr. Shakhashiri said, to try to reduce the amount of meat in your diet, because meat has a lot, the animal that you're eating themselves had to eat over their lifetime and stay warm and exercise. And so for all of these reasons, it's just more sustainable, low carbon to eat vegetables directly. And it's also healthy and delicious, although I'm saying that as somebody who really does like a good cheeseburger. So it's not saying you have to go all or nothing, but more saying that there's just small changes you can do, and thinking about, where our food comes from and how it's packaged, I think also helps understand where solutions might be hiding in plain sight, not just for you personally, but for the whole society.
Professor Shakashiri.
What else can be added to what Tracy just said here? That I concur with what she said eloquently, and that's a very good question, Zara. And all the questions have been good, and that's what we want to do, to engage in conversations about global warming, so we understand what is happening, we understand what we're doing, we understand and then take action that would reduce and help mitigate global warming. So thank you, Tracy, for being so elegant. And with the success of the group that you have founded, can we have also, is it only moms that can do science? How about dads? How about granddads? How about all of us? How about kids doing science?
Of course, the more the merrier. Really the Science Moms program was not saying only science moms, but I think actually there aren't as many role models of women doing science. I think a lot of people, when they think of a scientist, they think of a man in a white coat in a laboratory. And that is wonderful to have those grandfathers and fathers and men. But I think it's also important to shine a light on the women that are doing a lot of science as role models, but also to kind of focus on recognizing that there's a lot of different audiences out there. There's the folks who watch the Discovery Channel and who read Popular Mechanics and who come to Wednesday night at the lab. But there's a lot of important communities out there, and just having different channels to reach different audiences. But absolutely, everybody should feel totally welcome at Science Moms. Everybody has a mom, so certainly it's open to all.
Thank you very much. Bia, would you like to read the question from Raj?
I was going to ask if Raj would like to say it out loud, but I definitely can read it if he doesn't want to.
Yeah, I think he wants to. Oh, go ahead, Raj.
You can go ahead and read it. Thank you.
Thank you, Raj. And you're up, Bia.
All right. Raj says, the Montreal Agreement took care of ozone problem by banning refrigerants that contribute to it, but they pose problems concerning climate change, and the extensive research now on refrigerants for air conditioning systems and better refrigerants are being deployed to reduce GHG emissions. And then he says, NIST, the National Institute of Standards, is currently researching on refrigerants for a wide variety of applications, including for millions of auto vehicles using refrigerants causing significant GHG emissions. Any thoughts from the speakers?
Well, since I brought up the ozone hole, I'll just address that to say that the chlorofluorocarbons that were destroying the ozone layer also were powerful greenhouse gases. So, in fact, the Montreal Protocol helped solve the ozone hole problem, and it reduced this whole group of greenhouse gases. The problem that Raj is bringing up is that the replacement chemicals are not so bad for the ozone hole, but are still greenhouse gases. So you're absolutely right, Raj, that this is not a solved problem, but the efforts to move away from the CFCs have been a big benefit to climate. So it's not a trade-off, but it's more saying that there was something where we've had a win-win solution, and now we've replaced it with something that is good for the ozone hole, but is still a problem, less of a problem, but still a problem for climate change. So, I think the research is important, and thinking about new technologies to move away from emissions of all chemicals, even if they have different types of negative impacts.
May I just make a comment related to this, but also to invite everyone, when you have a chance, read the Paris Agreement. It's only 16 pages long. The Paris Agreement, it's an agreement. It's not a treaty. It's crucial that we understand what it is that so many nations have agreed to do, including ours. We can't be the only players in this. And you can find the Paris, I have it listed on my website. If you go to scifon.org, you'll see on the front, you'll see that same slide I showed you before, that global warming is unequivalent. And right underneath that, a couple of clicks will take you to it. 16 pages long. It's important that we really support our elected officials and everyone that around the world that should subscribe to the Paris Agreement.
Does anyone have a question they'd like to pose to the presenters? And if not,
I have a question.
Good, Raj.
According to the current climate change plan by the administration, they want to do net zero emission by 2050. As I understand, net zero means if, say, a building consumes energy, the amount of energy you intake is compensated by having renewable energy that you save. So in essence, whatever energy you may use from non-renewable energy source, you kind of generate your own energy, renewable energy, and use it for other purpose. So in balance, you are not consuming, you are not emitting CO2 as you would normally do if you didn't have renewable energy. The point I'm making is, does it mean that our CO2 level will keep increasing, but at every stage, we will supplement it with a renewable energy? So whatever increase in CO2 we take, it's compensated by renewable energy. Or does it mean that by 2050, we will keep the CO2 level as to where it is now? I think about 5,500 parts per million or so. Is that the plan, if I understand correctly? Or is it one of compensating for consuming energy by generating renewable energy? Can the speakers address this problem, please?
I think I can address it. I think, first of all, to say that when they're talking about net zero, they are talking about emissions, the release of chemicals into the atmosphere. We are one country. There's other countries who are also emitting. So what's going to happen with that, the parts per million in the atmosphere depends on what everybody is doing as it affects. But what the net zero terminology means is that not so much, I guess I don't think of it the way that you phrased it about offsetting energy with renewable energy. It's more that we want our energy to be provided by zero emitting sources, so that if you turn on a light bulb, that light bulb will be powered by a power plant that might be solar, might be wind, might be nuclear, but that it's coming from an energy source that does not burn fuel. If you drive an electric car, then it may be charged with a non-emitting electricity. So if everything were absolutely non-emitting, then we wouldn't need the net word. We could just say zero emissions. But I think there's a recognition that by 2050, we may not be entirely away from fossil fuels. There may still be use of natural gas, which most of us here in Wisconsin use for our home heating, for example. There may still be natural gas or coal or other sources for industrial processes or electricity. And so the net comes in with the idea that then we would capture that carbon emissions and trap it. There's one way is to capture it before it goes into the atmosphere and put it underground. A more low-tech way of capturing carbon is by planting trees, because when trees grow, they suck carbon out of the atmosphere. So the idea with net zero carbon is to try to make everything as zero as possible. And then the remaining fossil fuel that we can't zero out, to balance it with sucking the same amount of carbon out of the atmosphere using technologies we may have today and technologies that are being developed and will likely be more cost effective in coming decades.
Thank you. I have a follow-up question for you. If this is the way you are going to address climate change, can we not use another parameter as a mark of our success in climate change by saying the GDP every year we will maintain at 5% or 6% or so, and that we can couple with the emission criteria. So we have two optimization criteria, one to make sure our economy doesn't suffer, and the other to make sure we address climate change. So we bring the GDP into the equation, and so that we satisfy that we don't sacrifice our economic growth. At the same time, we make sure we don't suffer from climate change. Any thoughts?
Yeah, I mean, I'll say that one of the ways that people often think about carbon emissions is to recognize that you have economic growth, and then you have sort of the energy used per economic growth, and then you have the carbon per energy. So you have, three different things. The economy is its own thing. The energy used per unit of the economy is a different thing. And then the carbon emissions per unit energy is a third component. And if we move toward having a zero carbon or a net zero carbon energy system, then you're saying you could have zero carbon for energy use. And that doesn't affect what's going on with the economy, and it doesn't necessarily affect what's even going on with energy. You could still turn on your TV and drive a car, but if it's coming from a zero carbon electricity grid, then there's the potential to be not emitting even as we use energy, even as we grow the economy. And so, I think that there's a lot, we could go down this rabbit hole for a really long time. There's lots and lots of different policy and economic considerations when it comes to climate. But I think just to keep in mind, when people say net zero carbon energy, the idea is let's get the emissions to zero, and then we still need to be growing our economy. We're still going to be using energy, but just non-emitting energy.
I have a question.
I would just add just two quick comments, because Raj brings up the complexity of the situation that we face here. So, people talk about sustainable growth. That's an oxymoron. You think about it. And then the other point I make is that we have to hold ourselves and our elected officials not to play any shell games, which is kind of a little bit what I took from what Raj was trying to clarify. We're not playing games here. The fate of the biosphere is in our hands, and we can do a lot. We can't stop global warming. And let me just say this again: we can't stop it. There are natural causes, as Tracy mentioned, but there's nothing that has been happening in history that comes close to how much carbon dioxide we have put. The success of the Industrial Revolution is huge. It has helped us in so many ways, but there are dire effects, and that's what we're talking about. No shell games, no trade-offs that are not real trade-offs. And in this connection, if I might just say one more thing, Earth Day is just in a few days. Let's all think about planting trees, as Tracy suggested. Let's try to stop deforestation. let's try to be responsible in individual and collective action that we take. I'm sorry, there was another question that I interrupted.
Yes, Joseph Bluestein, I believe.
Yeah, I had a question about what is the impact of like a major volcanic eruption on climate change? I mean, we've seen some of these over the last, 50 years or so, that there's been some of these major volcanic eruption. I was just wondering, how big of an impact is that?
Yeah, so you can see when these volcanoes explode, they put soot and especially sulfur dioxide, and they explode with such force that it goes all the way up into the stratosphere, which is to say above the clouds, above the rain. And once it's way up high above the rain clouds, then it lasts up there for years before it is destroyed. So one of the biggest impacts of volcanoes is that you can see that the Earth often cools, even on a global average basis, after a major volcano. And that's really because of these sulfate particles that act like kind of like little mirrors in the atmosphere. They bounce the sun back and cool off the planet. And they stay up there because they're above the rain clouds. So it doesn't change, these volcanoes don't change the trajectory that we're on, but they do have a big impact for a couple of years after the eruptions, for the really big eruptions, not for all volcanoes, but for the ones that are so powerful that they shoot up into the stratosphere.
Thank you. Bia, can you read the next one from the text, please, from the chat?
Yes. I'll read the first question from Rogo, and I don't know if Rogo finished this all the way, so feel free to step in if there's more to this question. But it says, I have a boiler that runs on natural gas. Are you suggesting that I try to get an electric boiler or water heater? So is that the trend, to keep electrifying everything and then it gets cut off? So if I'm missing anything, feel free to jump in.
Down below, it continues there. You can read that two down.
Okay, so then it keeps going to say, it is hard to adjust the thermostat with a boiler because the technician suggested it takes the tank of water too long to adjust the thermostat. So just find a comfortable temperature setting and leave it at that until the spring. Is this a bad thing?
Tracy.
Well, I'll tackle the electrifying question. So I'd say this is something that is a hot topic of research and analysis, because already in the southern U.S., home heating is most frequently electric. But here in the Midwest, it gets so cold that natural gas is a more common heating for water and home. But I think there's a lot of building engineers and energy analysts and researchers who are trying to figure out what is the technology that would make it cost effective to use electric for heating in cold climates, or what is the threshold that would make it, maybe not everybody, maybe not up in the UP or Alaska, but maybe more people could be getting heat from electric than are now. So I'd say this is really a trend that nobody was even talking about 3 or 5 years ago, and now is a very active topic in energy efficiency circles, in carbon solution circles, in building solutions, is thinking about what can be electric, when should it be electric, and especially when it comes to home heating. Home cooling is already electric, but for home heating in cold climates, I'd say it's something that sort of people are trying to think about.
This also relates to something Tracy mentioned before about how the electricity is generated. Very good questions. This is a very good conversation.
And I've got a train going by, Bia, so if you could handle the next questions for the next minute or so, that'd be great.
Sounds good. The next question is also from Rogo. What do you think are some of the most positive things about the climate accord?
What the positive things? One of the bigger things is that so many nations are getting together and wanting to take responsible action. Another one is they're all spelled out in this 16-page document that I mentioned to you. It's not very long. It's that's why I urge you to read it, to make so the commitments that have to be made. And Tracy alluded to this. You know, all of these emissions, they don't have any geographic boundaries. They're all over the world, and so we have to try to work together, especially with the high density population areas in the globe, in Asia, where they're I'm talking about China. Let's not mix words here, so that we all work together to use less carbon dioxide producing energy sources. That's crucial. You know, we all like to stay warm. I mean, the carbon dioxide and all the greenhouse gases, they act like a blanket. Yeah, we want to stay warm, but we don't want to overheat. We don't want to overheat. And so I would say the commitment that is being made in the Paris Agreement, if it's accompanied by the will of the people in the countries to act responsibly, I think that's very significant. That's very significant. I don't want to see, and others don't want to see, the Paris Agreement fate be like the League of Nations in the 100 years ago or so. We want it to be successful. You know, as I say, and I'm not a gloom and doom person, but the fate of the biosphere is in our hands. We can do something. We can take responsibility for it.
Awesome. Thank you for answering that. Does anybody have a spoken question they want to say? Okay, I will move on to the next question in the chat, and this is from Sandy. Sandy asked, net zero at T = 0. Does that include embodied energy with an M?
I don't exactly understand the question with the EM.
Sandy, do you want to elaborate a little more on that?
Energy is just another way of including the global warming in energy. But when I talk about the embodied energy, when you first buy an electric car, it has more embodied energy than an internal combustion car. So you have to drive it pretty far to come out with a lower carbon emission than the electric car has driven much farther than the internal combustion engine, and that's because of the embodied energy.
I see. That makes sense. The terminology that I often use for that is life cycle analysis, the life cycle energy, sort of the wells to wheels. And you're right, with any technology, because the carbon stays in the atmosphere for such a long time, we can't just consider the end use. But for many energy, many of the appliances or cars that we use, the number one emission source, the carbon, is in its use. And so when it comes to vehicles, if you look at the life cycle assessment analysis of carbon, some is in the production, but most is in the use. So moving toward a cleaner vehicle is a win. And same way with light bulbs. LEDs take a little bit more energy to make than a incandescent bulb, but most of the energy is in the use. So you save so much more. So life cycle analysis takes this into account. There are many studies that have done this for all sorts of products, from plastic versus paper bags to vehicles to different types of coffee. And you know, sometimes the waste is a win for one product, but the energy and carbon is a win for the different product. So, you know, I think it depends exactly what you're looking at when you think about sustainability. Are you looking at a chemical? or energy or carbon or solid waste. But for in terms of carbon emissions and climate change, electric vehicles are a win under any analysis that I've ever seen.
Awesome. Our next question from Rogo: how high would the water level be if all of the ice melted at the polar caps, and would life on Earth still be possible?
I'm sure someone has done that calculation, but I don't know it off the top of my head.
I don't know what. Yes, but you can go back to that slide that I was showing the trend. It's the rise will be. We have to look at the mass of the glaciers and then yeah, but boy, if we start thinking about melting the polar caps, boy, that's a lot of heat that we would have put in the atmosphere. We want to try to avoid that. We want to try slowing down reaching that. So, but I don't know the exact answer to your question.
Well, can I make a comment? I mean, I think life will go on, but maybe the human race will become extinct. Life will go on Earth.
Well, to Joseph's point, I remember I was teaching a class a few years ago, and we were talking about climate change and talking about the science and what we know. And one of the students said, well, you know, I thought climate change was going to destroy the planet, but it's not going to destroy the planet. And I said, no, nobody's talked about destroying the planet. What we are destroying is the ability of humans to continue with our current way of life on this planet. So yeah, I think that your point is very well taken, Joseph.
If I could ask a question now about Biden's administration just released their first science budget. It totals up to more than $160 billion, which is astonishing. I'm wondering if you've had a chance to see that and what the implications are for this kind of science-friendly administration, especially when it comes to that kind of budget.
I haven't looked at the details yet. I mean, it just came out. But I take from the headlines that I have seen that these are steps in the right direction if we use the funds properly. If we continue to support research and development to understand more about our interactions with the planet, if we take responsible action to use alternative sources of energy. So I haven't studied that, but I'll tell you, this is a very different feeling that I have now, knowing that this is being proposed than a few years ago. And of course, the Congress has to act on this. And so this is why it's crucial to try to influence public sentiment. This is the message of President Lincoln, is to try to affect the sentiment of everyone in the population and have it be reflected and acted upon by our elected officials. So I will be looking carefully at the details, and I will be in contact with my elected officials in the Congress, both from Wisconsin and from other states too, because this affects everybody, not just our own localities.
I have nothing to add to that. But
Thank you. NBA, do you want to read the next question, please?
Yes, this question comes from Dareth. She asks, regenerative agriculture also may increase the carbon dioxide trapping in the soil. Have these methods been studied to quantify their contribution towards lowering carbon dioxide in the atmosphere?
I know one person who's been working on that is Professor Chris Kucharek, who's the chair of the agronomy department here at Wisconsin, and he's done research to quantify how switchgrasses can absorb carbon and bury it in the roots and serve as a net sink. So there's a lot of research on that going on right here at Wisconsin.
Regenerative agriculture is not just growing alternate crops. It is also cropping methodologies. I don't know a lot about it, but one of my daughter's high school friends is actively farming in Texas in the regenerative agriculture mode. And part of what they're doing is trying to structure how they do things like turn the soil with the livestock that are producing the manure rather than perhaps what we would think of as more big industry agriculture, plow, disc, harrow, seed. Something in between that is no-till planting. And what he has been saying to me is this actually traps more carbon than it releases, and yet he's running livestock on the land, in his case, pigs. And I was wondering, do we have any research to back that up?
There may be research on sort of some aspects of that. But I don't, you know more than I do on it.
And I know relatively little.
No, there are studies. I remember at one conference I was attending, someone from California doing studies on that. There are studies, all kinds of studies. That's what we need. We need more investigations and explorations. So we try to understand the different dynamics of what we're doing and what we should be doing.
And then Bia, can you read Dara's next question there about the built infrastructure?
Yes, so the next question, we have a large built infrastructure. How much can refitting the buildings, offices, factories, homes to be more efficient to possibly be net energy producers? Is that feasible?
Yeah, I mean, I think that there's a lot of opportunity. It depends on the building and where it is and some of these things, but just as some examples, Dr. Shakhashiri mentioned putting LED light bulbs in. That's a simple retrofit that can save energy. Another is when you're updating your refrigerator. In many homes, a refrigerator is the #1 use of electricity. And so buying an energy efficient refrigerator, maybe one that's a little smaller, can also be a big part of moving your home and other buildings toward being more energy efficient. In terms of being a net energy producer, one of those strategies for that is to put solar panels on the top of the building. And rooftop solar is growing here in Madison. And actually one of my colleagues here at Wisconsin, Greg Nemeth, wrote a book called How Did Solar Get So Cheap? So the cost of these solar installations, both industrial and rooftop, is coming down. So I think that there are different solutions that can be put together for different buildings. I'm speaking here from my home, which is over 100 years old. And so, and when I moved in, there was no way to keep the first floor warmer than about 50 degrees in the winter. It was so cold. And so we were spending all this energy heating the home, and it was going right out through the windows. So one of the things we did is we put in new windows, and now it's a much more comfortable space, and we're saving energy and reducing carbon emissions.
I would add that individual responsibility, might add just a little tiny bit, maybe even a minuscule bit, but we have to scale that up, and we have to get others to do similar things, others in the community. So I think it starts with the individual initiative and to be, taking care of heating issues like Tracy just mentioned. Now she's comfortable and the family is comfortable. Well, let's make sure that other people are also following that step.
And I was thinking of the for instance, I'm an apartment dweller. I don't have control over how the apartments
Okay.
were originally built
Yeah.
and insulated or not, double glazed, how well the caulking was kept up or the weather stripping. But we have lots of roof space. It would make sense at some point for it to be economically viable, I would think, for the management company, not only to convert, and they have, the hallway lighting to LEDs, but to add rooftop solar. And I'm wondering, how can we structure our national energy goals to encourage that kind of refit of our already built infrastructure? You know, I've changed my LEDs. I save $20 a month in this apartment, just changing the light bulbs.
Any suggestions for Gareth's questions?
Well, go ahead, Tracy, I'm sorry.
No, I was going to say, I think programs like the Focus on Energy program that provide advice to homeowners and business owners on ways to improve the energy efficiency of their building, you know, and Focus on Energy is funded by the utilities. So, you know, I think that having programs in place, and also programs in place, importantly, to support renters, because sometimes it's the landlords who are the ones deciding what the windows look like and whether there's caulking, but it's the renters who may be paying the utility bills. So I think that, just like you're saying, having system-wide programs, incentives, education, and you know, I think the good news is that for many energy efficiency measures, they pay themselves back, that you're saving energy, you're saving money, but some of them do require an upfront cost. So things like tax incentives or you know, or rebates or things like that can go a long way toward helping people learn about opportunities and take the right steps.
I like what you said, that, you know, the people living in the building, in the apartments in the building, maybe everyone can get together and have friendly, respectful conversations, talk to the management, talk to the owners, talk to the landlord. This is a collective responsibility. So I think this is, you know, having these kinds of conversations with people in the same building, as I say, friendly and respectful, I think that's a good step.
Then there's a question about, what about geothermal? Would either of you like to speak to pros and cons of geothermal?
I mean, I think geothermal is, you know, it's good to have a diverse portfolio, and different renewable options work better in different environments. Geothermal depends on some of the geological properties of a region. So some areas are well suited for geothermal heating and cooling. Some places even have geothermal electricity production, but in other areas, the geology of the place doesn't support that as well. So, you know, I think that there's no one silver bullet. It's having a combination of technologies. And I'll just say, even now, if you look across the United States, where do people get their home heating from? Some places it's natural gas, some places it's electric, some places still rely heavily on oil. If you look at where people get electric from, some places it's in the Pacific Northwest, hydropower is a huge source of electricity. Other places, including Wisconsin, have a significant share of coal, nuclear, natural gas. So, you know, our energy system is designed to draw from multiple different sources of energy. And I think, you know, thinking about a clean energy future, geothermal will be part of that, just like solar, just like wind, probably nuclear. You know, I think thinking about this as a portfolio of options, and thinking about which is the best for a particular building, for a particular application, in what space.
For us here in Madison, Tracy, I wonder, would you care to say something about the solar farms that MG&E is now?
Well, you know, I haven't looked at those. I haven't done any investigation of those specific solar farms, except to say that, you know, we don't have that much sun here. Some people, you might think, but Actually, Germany has more solar as part of its electric grid than any other country. And actually, Germany has pretty much similar climate to what we're here in Wisconsin. And it's a similar sized country. So I think this idea that solar can only be viable in Arizona just isn't true. So I think it's great that MG&E is investing in different technologies as well.
And I know about it a little bit because I subscribe to it. I just joined last month. We all have to take individual action and be supportive of our local industries because the complexity of the economic complexities and the scientific issues and so on, they all are in play. And we just have to be confident about what we're trying to do here.
Mm-hmm.
And then we're at 8:31, so we have time for three more questions. The long one in the chat, if the two of you could please read that, because I think the question at the end is, the final question is the key one. How can we use science to help create justice for communities? So there's this equity, social justice angle for all these kinds of questions on climate change, energy sources, who has to change what. So if you can speak to the how do we help create justice for communities question would be great.
Well, the population is not located in one area only. We have to be not only aware but concerned about having access to electric power, in rural areas as well as in metropolitan areas. I think we have to be take. The way I feel about it and others feel about it too, we have to have a social contract. We have to have a social contract that enables us to do the research that we do in science, but we also have to meet the expectations of everyone in society. And so I think it's important to think about this question about the reaching and being subscribing to the social justice as it relates to the uses of energy, in addition to being concerned about how the energy is generated and how we can all live comfortably and hopefully happily.
Yeah, I mean, I think that the question is really sorry, it's getting a little late. I'm getting a little hazy, but yeah, I mean, environmental justice is a huge issue, and it takes place in terms of, as you're saying, the impact of the climate on individuals. And actually, many disadvantaged populations are in large cities with big urban heat islands and lack of access to air conditioning. You have issues about the energy itself and how much is it costing to get from your home to a job? How much is it costing to live in an apartment that you can keep at a comfortable temperature through the year? So you have the justice issues around energy use, justice issues around climate impacts. You also have justice issues around air pollution and emissions, in the sense that you have if there are initiatives to move toward clean energy, to make sure that they're not benefiting just the wealthiest communities, that they're benefiting traditionally underrepresented communities. And especially when it comes to air pollution, this is really one of the sort of touch points when we think about environmental justice and climate, because we're taking measures, we're investing in ways to reduce carbon emissions, but we know that those steps also lead to cleaner air. But whose air is getting cleaner? And that's a sort of the question of these immediate local benefits. And so there's a lot of work going on. I have a graduate student named Kieran Gallagher, and this is really the focus of her PhD, looking at how do carbon policies translate into environmental justice issues. And it's a little different than what you're talking about with the rural desert, but I think that they all tie together. If you're thinking about who's getting the clean air, who's getting the cleaner energy, who's electricity bills are being changed. And we really want to be conscious about all of these things. And I think, though, coming back to science and what is science doing here, we can't say that science and values are disconnected. They're not. But there's also different roles for different individuals. And I think that like understanding the climate is a problem and thinking about sort of what happens to the atmosphere, what happens to energy systems, those are questions that then can be part of a conversation, a democratic conversation, a social justice conversation with the people in the communities who are affected having a big voice. We don't want this to be a technocratic decision-making where just some academics and officials make the decisions. You need to have community voices involved and to try to get the word out so they feel empowered and understand the issues.
Thank you very much for that assessment. And with that, I think we ought to wrap up. I appreciate everybody coming. Professor Shakashiri, Professor Holloway, thank you for sharing your insights and analyses. Bia, thank you very much for running the technical background and fielding and speaking the questions and giving voice to the folks who typed the chat questions. Thanks to everybody who came and participated. I really appreciate it. It's a great way to have a Friday night conversation for UW Science Expeditions. Do tune into things tomorrow and Sunday. You can go to science.wis.edu/science-expedition and see the lineup there. And with that, I'm going to turn the YouTube recording off. And I think Professor Holloway's got a 1-year-old and might have to peel off here. And if anybody else wants to hang on and do a little linger at the lectern, that would be fine with me.